Okay guys, final two rules for indices, rule 5 and rule 6. This is dealing with positive and negative indices, or should I say the index is positive or negative. And what I mean by that is if we have something like a to the power of 3, that has a positive index because that's positive 3 as the power. However, if we were to have c to the minus 4, then the index is negative and it's minus 4. And how do we deal with changing from a positive to a negative and vice versa? So what I want you to do here is I want you to focus on the rule number 5, which 1 over a to the power of m. As you've seen before, we use the letter m and n to try and signify this, but the examples themselves will make it a little clearer. So if we take the rule down to inspect it in a little more detail, I can explain what happens at this stage. So there is a step in the middle that's a little missing, has a little bit missing here. What we're doing is we're changing that 1 over a to the power of m, and we're bringing the a to the power of m to the top. So at the moment, the a to the power of m is a denominator. We're going to bring it to the top, and that's what allows us to change the power to a negative. Okay, now in every case when we do this, we can't just ignore the fact that there was something that sat alongside the a to the power of m. There was if you want, an invisible 1 in front of that. So that 1 remains underneath. But we know from the dealings we've had before, if you divide by 1, it's the same as a to the power of negative m on its own. So that's why it looks, or it appears, as though this green section has just been ignored in the rule. That can be said also on the reverse, and it's something worth pointing out. So equally, if we were moving from a to the power of negative m and we wanted to make it a positive power, then we could jump to a to the power of m. Because it skipped from the top to the bottom, then this negative becomes a positive. But what's actually happened there is we've taken, again, the invisible 1 that's at the front, it stayed on the top, or not stayed on the top, it's appeared now on the top, and the a to the m is down the bottom. So you might have been looking at that and saying, well, how do we go from a to the power of negative m to 1 over? Where does that 1 come from? It's the 1 that is at the front, and we need to remember that. So now looking at the first example, again, let's change the a to the power of 2 to a negative power. We've got 1 over a to the power of 2. So to make that a negative power, the a comes to the top, the a to the negative 2, because we've brought it to the top. And once again, there is an almost invisible 1 at the bottom and at the top that we ignore, which should just leave us with our a to the minus 2. That's something that's relatively straightforward. Okay, the second example, and how that might be pitched is it would be simplify leaving your answer as a positive index, or leaving as a positive index. So combination of some of the rules we've used before, 1, 2, 3, and 4. So starting us off, we've got p to the power of 6 over p to the power of 8. We know when we have powers that are being or terms that are divided, we would subtract the powers. Now this is an interesting one because we've got 6 subtract 8. That's going to give us a negative value. So that's negative 2. Now that on its own will then be cubed, but it's not just the 2 that we're dealing with, it's the whole term altogether. Now we're fortunate where it's a single p, so that won't impact in this case. But so what do we do when we've got powers inside and outside the bracket? We take those 2 values and we multiply them together. So p to the power of minus 2 times 3, which is minus 6. Now ordinarily that would be quite an acceptable answer to leave, but this question is specified, please leave as a positive index. So a couple of things we've mentioned before. There is an invisible 1 at the front of the p there that we need to remember. So it's not just straightforward, we leave the p at the bottom and make it the to a power of positive 6. We're now left with something at the top that we need to fill. Now, in this case, it's a 1 because it is at the front there. I do want to mention what would happen if it's, the final answer we had was 2p to the power of minus 6. That 2 would not come down to the bottom and you leave a 1 at the top. The 2 would be staying where it is, and the answer would be 2 over p to the power of 6. But for the purpose of this question, it's just a 1 at the front, so it's 1 over p to the power of 6. Okay, another example on creating a positive index. We have 10 over 2x to the negative 1. Now, this is a fraction, so therefore a divide. We want to keep that in mind. So the first step here we would like to do is we would take the x to the top. So it's x to the negative 1 currently. So when we bring it to the top, it will become x to the positive 1. Now, this is the part that often causes confusion. People, or students should I say, want to bring the 2 with it. But then what do you do with the 2 and the 10? Do you multiply it? We need to remember that when we're moving things here, we're only moving the x. So that 2 remains on the bottom. Okay, we're not going to remove the 2 and the x at the same time. That leaves us with 10 x to the power of 1 over 2, which is 10 divided by 2, or 10x divided by 2. We don't need to have the 1 in there, so 10x divided by 2, we know 10 can cancel out and leave us with 5. So that would leave us with 5x. Okay, or in a more straightforward way, 10x, half of 10x is 5x. We're therefore left with a positive power that we don't put in there, but we know that we have a positive power of 1 that we just wouldn't put in. Okay, before we move on to rule 6, we need to have a wee look at cubes. So much like the work you've done previously with square numbers, if you take a cube of a value, so a to the power of 3, what that means is it's a times a times a. So square would have been just the 2, cubed is times 3. So as you can see, 1 times 1 times 1 doesn't really change anything. So it's 1, 2 times 2 times 2 gives us 8, 3 times 3 times 3, 27, and so on and so forth. So what we want to do is we want to familiarize ourselves with the more common cube and terms and the cube roots. So obviously, cube root is that bit more difficult, but similar to the work we've done with squares. So if we have the cube root of a number, so for example, if we took 125, the cube root of 125 would line up similar to a square root, but this time there'll be a little 3 in the tick there. So the cube root of 25, working back the way, is 5. We want to be familiar with as many of these as possible. It's not always incredibly feasible for you to remember all 10 there. There are some common ones. I would say the most common being the 4 in the middle there, 2 to 5. So 8, 27, 64, 125. That's not to say that the others won't feature. So yet another table that we want to try and learn, or at least do some practice with at home, something you could put on flashcards. You can ask your friends to test you. Cubes and squares, something that we want to spend some time on. Okay, fractional indices and transferring from a fractional index to a sub. In the first instance, this rule, this is one where I would effectively say, I don't want you to remember the rule using the rule that you see on the screen. We are going to remember the rule using the most common fractional index. Okay, so the most common fractional index you'll see is x to the power a half. And I actually want to start in the reverse here by just having a look at the square root of x. Okay, now within the square root of x, what I would normally do in the classroom is I would ask the room to see if they could come to the board or at least describe to me where there are hidden number ones. I'll often say that the number one is the most important number at Nat 5, and also remember that each letter has a 1 at the front. Equally, it could have a number 1 at the bottom, because if we divide by 1, it stays the same also. And we have seen from the previous example that the power 1 is also something that could be hidden. Okay, so there's 3 in there, and I wouldn't want us to focus on all 3 for now. The most important one we're going to look at is the power 1, something that we've seen before this, power 1. Okay, I also want you to focus on the square root symbol. What does this square root symbol actually mean? What's happening is we have the square root of x. What actually has happened over the years is there's a value that should go in here and should go in here, but they've dropped off. If we were dealing with the cube root, then there would be a wee 3 in here. The number above the x, as we've seen before, is a 1 that's missing. So the cube root or the square root has disappeared, and what we want to do is to reinstate it. Because it's not a cube root and it's a square root, we are going to put it in, and this time it's going to be a 2. So the square root of x, although often written just with the root sign and the x underneath, like so, actually has a 2 in here and a 1 in here. Okay. And that's the rule I want you to remember. I want you to remember that the square root of x is the same as x to the power a half. Okay, and what that will do is it will let you see that the 1 will be on the top of the fraction and the 2 on the bottom of the fraction. And whenever faced with a similar scenario, whatever way you're moving, you can remember that x to the power a half is the same as the square root of x. If you write that down, use that value to decide where they should be positioned. So, for example, if I was asked to change the x to the power of 4 over 3 into its third form, then what I would do is I would take a little piece of paper or write it at the top of my jotter to say, well, I know that x to the power of a half is the same as the square root of x. What that actually means is there's a 2 in there and a 1 in there. So if we have the same thing, instead of it being the square root of x, we can put the x in. The 2 would go inside the tick. So in this case, this 3 is what's going to go inside the tick. And the 1 was next to the x. So on this new term, this 4 will go next to the x. So we have the cube root of x to the power of 4. There is another example there. If we take a look at the fifth root of y squared and we go in the opposite direction, and if we choose to change this into index form, then again our x to the power of a half equals square root of x, the 2 and the 1. So over here we know that we're going to change this to y, and there's going to be a fractional index. The 2 was at the bottom of the fraction when it was inside the tick, so the 5 goes to the bottom. The 1 was at the top, so the 2 in this example goes to the top, and we're left with y to the power of 2 over 5. So the key thing here is for us to remember or try and use this example here. X to the power a half is the same as the square root of x. And for me, that's the best route to remember the rule. Rule 6 up on the left-hand side with the a and the m over n is good, but for me, the most common one where it's x to the power a half is the square root of x, and ensuring you input your 2 and your 1 and practice that, then you'll put yourself in a very strong position. Okay, exam type questions with fractional indices. If we have a look at evaluating a number like 8 to the power of 5 over 3. There's a couple of things that we need to do. So same thing as we've done before. What I would like to see is that we get into the habit of writing x to the power of half is the same as the square root of x. Input your 2 and your 1. That's our staple. That's what we want to be remembering and getting down on the exam paper or in your class jotter to help us solve this equation or this example. So evaluate means find a value, find an exact value. So we first of all want to change this into a root. So the 8 is going to be inside the root. Okay, where does the 3 go? The 3 is on the bottom, so that's going to be a cube root. Okay, and the 5's at the top, so that's to the power of 5. And where everybody struggles here is what order do we do this in? And what that is reading left to right is the cube root of 8 to the power 5. Now, we don't want to do the power 5. We don't want to multiply something by itself 5 times first and then have to work back the way. The cube root is going to make it easier for us. So we want to find the cube root of 8 on its own first. And then when you get that answer, evaluate it to the power of 5. That's going to ensure that you're dealing with a lot smaller numbers. So the cube root of 8, what number do we times by itself to get to 8? So we've done a little bit of work at the start of this lesson on cubes and cube roots. So something you need to work on. But the cube root of 8 is 2. So that's just replaced in the bracket. 2 to the power of 5. Well, 2 cubed is 8. 2 to the power of 4 is 16. And 16 times 2 is 32. So that's 2 to the power of 5. So 32. 2 times 2 times 2. And we'll put that up there. So we're looking at 2 to the power of 5 is 2 times 2 times 2. That's the cubed part was 8 times 2 is 18 times 2 is 32. So we've got 1, 2, 3, 4, 5 times we multiply. So cube root is of 8 is 2. 2 to the power of 5 is 32. And we've evaluated the fractional index. Okay, we'll go through another quick example. So we've got 16 to the power of 3 over 2. Like I said before, x to the power of half is the same as the square root of x. Get into the habit of writing that down. We have the number at the bottom, the 2 in this instance, goes into the tick, and the 1 goes at the top. So if we do the same with the 16, we have the root of 16. The 2 is at the bottom, so once again it goes into the front, and the 3 goes to the power of 16. So we now have the square root of 16 cubed, and that's the order we do it in. We want to take the square root first. So the square root of 16 first, and then cube the answer. So square root of 16 is going to give us 4. We know that from our square numbers. So that's 4 to the power of 3, or 4 times 4 times 4. So we have 16 times 4, which is 64. And we've evaluated the fractional index.